Welcome to question 15 of the 2007 Mathematical Methods Exam 2. In this video, we will be looking at the solution for this question. A reminder that this video is in no way endorsed by VCAA. Now, before we move on, I'd just like to point out that the use of a CAS calculator is not really appropriate for this question, although consulting your notes may be useful in an exam situation. So for question 15, we have the graph of the function f with the domain of 0 to infinity, where the rule of f of x is equal to 3 times x to the power of 5 on 2, is reflected in the x-axis, and then it is translated 3 units to the right and 4 units down. So some of you may look at a problem like this and be able to inspect and work out what's going on pretty quickly. So I'll show you that method first, but then I'll also show you how to use mapping for this sort of problem, which is a robust method that would work even if the problem got substantially harder than this. So if we look at the three transformations that I've underlined there, the reflection in the x-axis will result in a negative appearing out the front of the rule. So any of B, C, and D are still options at this stage, but we can rule out A and E because they don't have the reflection we need. Next, if we want to translate the graph 3 units to the right, we actually need x subtract 3 inside the rule. So that appears in B and A, but A has already been taken out, so it's looking like our answer is B. But we can check that the translation of 4 units down is in fact a negative 4 on the end of the equation. And B is the only one with all three of those things, so that means that B is in fact the correct answer to this question. Now, if you were to use mapping to answer this question, we would have started out with x, y maps to, and then we would have x, and to get the reflection over the x-axis, we'd actually need negative y. So our first set of brackets would be x, y maps to x, negative y, and then that maps to x, and then a translation of 3 units to the right in mapping, we'd actually put plus 3 in there, and then we'd have negative y, and then to translate 4 units down, we would put a negative 4 just there. So keeping track of the colors, that's where these 3 transformations would appear in mapping notation. Next, we'd say, therefore, x dash is equal to the x plus 3, and y dash must equal the negative y subtract 4. Then we want to solve for the non-dash terms. So this would give us x is equal to x dash minus 3. So that would get x by itself for our equation involving x and x dash. And then over here, we would have y dash and we'd add 4 to that, and that would equal negative y. So therefore, to get y by itself, we'd need to multiply by negative 1. So we'd have a bracket negative y dash plus 4. And then close bracket. So once we know what x and y are in terms of the x dash and y dash respectively, we can now substitute these into the original equation. So wherever there was a y, or in this case f of x, we're going to put negative bracket y dash plus 4, close bracket, and that's going to equal 3 times x, but x has become x dash minus 3, and that's still to the power of 5 on 2. And then we just want to get y by itself to finish off this problem. So taking the negative across by multiplying both sides by negative 1, we'd have y dash plus 4 is equal to negative 3 bracket x dash minus 3 to the power of 5 on 2 still. And then we'd subtract 4 to get y by itself. So our transformed graph, which I might call y1, is going to equal negative 3 bracket x minus 3 to the power of 5 over 2. And then we'd have subtract 4 at the end. And like we discussed before, that's where the negative arrives, reflecting it over the x-axis. Then the x minus 3 inside this bracket is responsible for that translation of 3 units to the right. And finally, the negative 4 at the end is the translation of 4 units down that we needed. So that shows that B is the correct option using mapping notation. And then finally, from the examiner's report, we can see that this question was exceptionally well done, with 95% of students getting the correct answer for this question.